8.9 is on systems of linear equations. You guys, at this point in your math career, should be really good at doing it with two equations and two variables. What's the difference in Algebra 2 is you're going to have 3 variables, 3 equations. Okay, so instead of just having x and y in your parentheses, you're going to have x, you're going to have y, you're going to have z. Every once in a while, they'll use some other variables like a, b, and c, or you might see r, s, t, but basically just keep them alphabetical. So if they use a, b, c, just put a first, b first, and then c first. All right, so when you're graphing or when you're solving 2 equations for 2 variables, there are 3 methods you can use, right? What are they? Elimination, substitution, graphing, right? Okay, you guys don't know how to graph in 3 dimensions yet. I say yet because that's coming, okay? So we're going to stick to elimination, and we're going to stick to substitution. These are the 2 main methods. Someday you will learn how to graph in 3 dimensions, but even Desmos doesn't graph in 3 dimensions, okay? And even if some of you I've seen have the graphing calculators, those are 2-dimensional, unless you have, like, I think it's the TI-89 will graph in 3 dimensions. Even then it's hard to use it and figure out where 3 lines are intersecting on a 3-dimensional plane. It's kind of a lot. Okay, so we're just going to stick to elimination and substitution for right now. All right, so we're going to start with an easy one. So example number 1, I'm going to give you 3 equations. What's nice about example number 1 is one of your variables is already solved. All right, so if your final answer is going to be x, y, z, z we've already got. So in the progression of these, if you get one that already has one of the equations solved for one variable, you're starting off good, okay? So in order to solve for the second variable, you're going to use that answer and plug it in to the other equations. So I'm going to plug it in to the second equation, and what variable will I solve for then? Y. So I'm going to take that 3, plug it in there, and I'll have 2y plus 3 equals 1. Subtract 3 from both sides. So I get -2, and then when I divide both sides by +2, we get y equals -1. I'm going to circle it. I'm going to circle it just so that I can find them easy at the end, okay? Sometimes on ones that are a little more complicated than example number 1, you end up having a lot more writing, okay? Then I'm going to fill it in here. Y should come second, so I'm going to fill in my -1 right there. And then notice I've got now solved for 2 variables. I'm solved for z, I'm solved for y. I can take both of those answers, plug it into the first equation, right here for y, right here for z, and I'll be able to solve for x. So I'm going to have 2x plus 3 times -1 plus 2 times 3 equals 13. At this point, I'm just going to say all that's important is make sure you're following order of operations. Make sure you're watching your signs carefully. That kind of stuff. Just basic, you know, are you a good mathematician? So we're going to go 2x minus 3 plus 6 equals 13, which combines to get 2x plus 3. Subtract that 3 from both sides. So 2x is 10. Thank you. And then we're going to divide both sides by 2, and we have our third variable is equal to 5. All right? So we're going to fill that in right there. Okay? Once you have all 3 of your variables, you're good to go. All right? Any questions on example 1? All right. So that's an easy example. Let's look at a slightly more complicated one that requires a little more work. Okay? So 3 equations. X plus y minus 2z is 7. Negative x plus 4y plus 3z equals 2. And 2x minus 3y plus 2z equals negative 2. All right, so think back to when you were doing this with 2 equations and 2 variables. One of the key things when they started to get a little bit harder was to stop and just look at all your coefficients, right? Look at all your coefficients in front of those variables and see, what would be easiest to work with, right? Because sometimes you have to multiply one or both of the equations by something in order to get opposites, right? Opposites is what's going to eliminate, okay? Sometimes it's real obvious. Sometimes you're like, oh man, I'm going to have to multiply 2 equations, both of them by something, okay? Anybody see this one? What? The first 2 equations, which variable are you looking at? The x's, okay? So right here and right here, your eyes should be drawn to that, right? You've got a positive 1 and a negative 1. So I'm going to take the first and the second equation and combine them. That's called elimination, or the addition-subtraction method. Or I've also heard it called linear combination method. But usually I just say elimination, but you can call it whatever you want. So I'm going to start by writing just the first 2 equations. So x plus y minus 2z equals 7. Negative x plus 4y plus 3z equals 2. All right. These are obviously going to eliminate, and then you want to combine everything else that's left. So 1y and 4y is 5y. Negative 2z and, is that a 3? Yeah, 3z is 1z. 7 and 2 is 9. Okay? I combined the first and the second, and I got it down to 2 variables. Now, I need another equation to get down to 2 variables. Okay? I have to use the equation that I haven't used yet. So I've used 1 and 2. I have to use the third, and then I have a choice of using either the first or the second. Okay? Whichever one's easier to eliminate the same variable I just eliminated. You see how I just eliminated the x? So I need to get the opposite of 2x. Which equation would be easier to use, the first one or the second one? The second one. Okay? Because I want to take the second one and I want to multiply it by 2. And that will give me opposites, okay? So the third one I'm going to just write down just as it is, 2x minus 3y plus 2z equals negative 2. And then the second equation, I'm going to multiply it by 2 and write it directly underneath, okay? So if I multiply this term by 2, I get negative 2x. If I multiply this term by 2, I get plus 8y. If I multiply this term by 2, I get 6z. And I always have to remember to multiply over here because that's the most common mistake. So 2 times 2 is 4. Now I can combine them, right? These should cancel. That was the goal. Then I combine everything else. So negative 3y plus 8y is 5y. 2z and 6z is 8z. And negative 2 plus 4 is 2. Now I have these two equations, right? And they're both down to the same two variables. Now it's just like you're in Algebra 1, right? You can combine, yeah, so now you've got two equations and two variables. And you need opposites again. So which variable would be easiest to get opposites at this point? The y, probably, because see how they're both 5y and 5y? The 5y and the 5y. So if I just take this one and multiply it by what? Negative 1. Then I'm going to have opposites. So this is going to be negative 5y minus z equals negative 9. And then directly underneath it, just write this one. 5y, 8z, 2. Okay? I'm about to get my first variable, right? So these are opposites, they cancel. I've got 7z here, and that's equal to negative 7. So when I divide by 7, I get z is equal to negative 1. All that work just to get my first variable, okay? But it'll go much faster after this. So for my final answer, z is going to be the third number, right? X, Y, Z, so that I'm going to fill in my negative 1 there, okay? I can take that negative 1 and plug it into, if I try and plug it into one of the three original, you can see that I would still have two variables. So I can pick either this equation in parentheses or this equation right here. Does it matter which one? No, pick the easier one. This one's slightly easier, right? So I'm going to go 5y plus negative 1, so like minus 1 equals 9. Add 1 to both sides. You get 5y equals 10. Divide by 5, so y is 2. So that's the second number. Okay. Now we just need our x, right? So I'm going to pick any of these three original equations. The first one looks easiest, right? So I'm going to say x plus the value of y, which was 2, minus 2 times the value of z, which was negative 1, equals 7. And then just simplify. So x plus 2, negative 2 times negative 1 is positive 2. This is 4, so I'm going to subtract 4 from both sides. So x is 3.